Alright, hey, you're at section 8.5, the partial fraction decomposition. You were given this one to integrate a 1 over 1 plus e to the x dx, and in order to use partial fractions for this, we're actually going to do this one two ways. But in order to use partial fractions on this, you have to start off with a quick trick. You have to multiply the integrand. You have to multiply the numerator and denominator by e to the x. So you have to rewrite this as e to the x over e to the x times 1 plus e to the x dx. Then it becomes a basic u sub. Let u equal e to the x. du is e to the x dx. So when you substitute in the denominator you have, well, u times 1 plus u. And then the e to the x dx is taken care of by du. And now you have the setup. It's the classic setup for partial fraction decomposition. So for this partial fraction decomposition, let me pull it on over here. 1 over u times 1 plus u. So you'd write that as a over u plus b over 1 plus u. Multiply both sides by the LCD to give you a 1 equals a times 1 plus u plus b times u. Pick some strategic values for u. Yeah, I'd pick u as 0. If I pick u as 0, I immediately get 1 is equal to a. And then, let's see, next strategic value, I'm going to write it right here, is I'd pick u equals -1. And I would have, see, that tells me 1 equals negative b. So b is equal to -1. So our integral that we had after u substitution, thanks to partial fraction decomposition, we can rewrite this integral as the integral 1 over u minus 1 over 1 plus u du, which is very straightforward. Natural log absolute value of u minus natural log absolute value of 1 plus u. And then we remember to resubstitute our u back in there. So we get natural log absolute value e to the x minus the natural log of 1 plus e to the x plus c. And I would go one more step here. You know, first off, the e to the x is always positive, so these absolute values are overkill. They could be parentheses. The same with these absolute values. But it's this first term, the natural log of e to the x. Natural log of e to the x immediately simplifies to x. And that's what we get. So this is what we get when we do a trick of multiplying it by multiplying the original integral by e to the x over e to the x. So we can then do a u sub, and we have something that's very friendly to crank through partial fraction decomposition. So write this down. That's what we came up with as the antiderivative. But I do want to look at this one and do it a completely different way. So let me erase. And this other way should look familiar. I think we've already done this integral earlier, like maybe back in section 8.1. I know we definitely did it way back in Calc 1. But to do this integral a different way, and it's a completely legal way, and it really highlights the fact that an integration problem is like a little mini puzzle. You have to think, you know, how are you going to crack the code of the puzzle? So for this beastie, I could start off by multiplying the numerator and denominator by e to the negative x. If I do that, we'll look down here in the denominator. 1 times e to the negative x is e to the negative x. E to the x times e to the negative x would be e to the 0, which is 1. Now I've turned it into a problem that is a basic u substitution. If I let u equal the denominator, du is negative e to the negative x dx, or negative du is e to the negative x dx. And when I substitute in, I have a negative sign out front. I mean, we have a very friendly integral. I mean, we immediately have negative natural log absolute value of u plus c, negative natural log absolute value. Okay, there's my u. So e to the negative x plus 1 plus c. That's what we came up with by doing the trick of multiplying numerator and denominator by e to the negative x and then doing a basic u sub. But the way we had just done it before, where we did partial fractions, we came up with the answer. Let me write this over here. So via the partial fractions, we had the answer of x minus natural log absolute value of 1 plus e to the x plus c. So again, it comes back to that old issue. If I did it this way, I get this as an answer. What if I look in the back of the book, and the back of the book has that as an answer? Which one of these is correct? Are they both correct? I think they should both be correct, but could we show that these are actually equivalent antiderivatives? And of course the answer to that is yes. And let me show you what you could do to this beastie to get it to match up with that beastie there. So let's take this and let me pull it over here. And let me start off by saying e to the negative x, you can rewrite that as 1 over e to the x. So I'm just doing one little step of algebra there. Alright, so one step of algebra. Now inside the absolute values I could get a common denominator, which is e to the x. And so see, this would be e to the x over e to the x. So that gives me 1 plus e to the x over e to the x plus c. And now we remember that old property of logarithms. When you have the natural log of a quotient, you can rewrite it as subtraction. So the opposite of, and I better put that step inside parentheses. So I'm using a property of logarithms to rewrite this as the natural log of 1 plus e to the x minus the natural log of e to the x. Well, the natural log of e to the x, as we saw earlier, the natural log of e to the x just simplifies down to x. And now if you distribute the negative 1, you get negative ln, absolute value of 1 plus e to the x plus c, which is exactly the same thing as here. So my hunch, and I haven't verified it, but my hunch is the back of the book had this as an answer because it was in the section on partial fraction decomposition, and so they wanted you to find a way to use partial fraction decomposition. And this is the answer that came about from doing the partial fraction decomposition. But that doesn't mean what I just went through here, something that we've already done. We've already seen this. It doesn't mean it's not valid. It is absolutely valid. And we have this as an antiderivative by doing the trick I just went over here. This is the antiderivative. Nothing wrong with it. And that's the beauty of like an integration problem. It's a little puzzle. How are you going to get started? And, well, just make sure however you get started, it's legal. But that's it for this one. Thought I would show you two different ways on how to attack it.